Cheaper, cleaner food. That's the goal of version 2 of my AI-powered sprayer drone.
Here you see the drone on an example flight. In the top right's a view of the route it's flying in Mission Planner. In the bottom right, you see the images the camera on the drone is taking of the ground below the drone. It uses a custom image classification model to determine if there's a weed or native grass below the drone, and it turns on a small sprayer to kill the weeds. At the end of the flight, it lands on the landing pad. It's pulled into the battery swap, recharge, and liquid refill station, and a fully recharged battery is inserted. Liquids are refilled, and then it's pushed back onto the landing pad and sent out on another flight. This video series is about how this whole thing gets built, and in this video, we are going to print, assemble, and set up Mission Planner and ardupilot to get our first automated drone flight off the ground. Head over to the Nathan Builds DIY/Drone V2 GitHub. That's where you're going to find all of the 3D models. You can see each one of these things in here. You just click on it and zoom in on it. And when you're ready, you can hit the download raw file over here and it'll download to your system. Each one of these things is, a pretty large print. This is like 350 mils on a side. Make sure your printer's large enough. I ended up having to go with the Anycubic Cobra 2 Max. I don't love the company, not great support. I don't even love the printer, but it is big and inexpensive, so I grudgingly recommend it, I guess. Anyway, you are going to print one of these drone bases. You are going to print 6 of these battery cages. This is where you slide in the 4S LiPo battery and then make the connections. These slide into the battery base. So I called it a charger spinner. These battery bays here, there's 3 battery bays in each one of these charger spinners, and I call it a spinner because it does spin around. You see this center axle right here. So print 2 of these things, and then you can see where that axle hooks in right over here. You're also going to print 2 of these. This is the sort of holster for that charger spinner. That axle will pop right in there, and then right over here is where the servo mounts, and between these 2 they hold up that battery bay charger spinner thing. So the last thing to print is this drone cup. Now I'm saying print all of it because you just need one of these drone cups, by the way. I'm saying print it all right now. As long as you're printing, just get it all done. It will take, this one right here is going to need an entire roll of filament, and the charger spinners need close to an entire roll of filament. After that, you can sort of piece it together. If you're really familiar with 3D printing, my recommendations are 10% infill on the drone base and the battery cages. They need to be lightweight, so keep those as lightweight as possible. Those are the things that fly. I did 100% infill on the rest of these. I printed everything in PLA in the end, and I used Flex Seal to waterproof these. You can just check in with us later to see that waterproofing process. I also printed these things in PETG, and I used acetone and was able to get them waterproof. I think you can use an epoxy resin as well. Didn't try that. But you basically, if you're familiar, go ahead, print these things and catch up with us later when we're actually doing the waterproofing and then assembly. If instead you were like me, who had no experience with 3D printing, follow along here and I'll try to get you up to speed on how you can make these things print. So the first thing you're going to need is, after you've downloaded these STL files to your computer, you're going to need to slice them up so that your printer can actually print them. I used Prusa Slicer. Not saying it's the best one, but I used it, it works. So you can go to their website and download for Windows. And then you need to get a profile for your printer onto Prusa Slicer. And Anycubic did actually create this article about how to do it, and they link to their own firmware and software page. So you head over here, go to the Anycubic Cobra 2 Max, and here's the Prusa Slicer, the Prusa Slicer filament profiles. That's what you would grab. It sends you over to a Google Drive. You download this .ini, and that is going to get you your initial configuration. Basically, it tells this thing how big the build plate is, and it sets a bunch of initial parameters. So when you open up Prusa Slicer the first time, you're going to get a build plate that looks like this. That is not yours. You need to go to Import, Config, and we'll go down here to Cobra 2 Max empty. So this thing right here is like a 400, maybe 400. Yeah, I think it's 400 on the side and then 450 tall, millimeters tall. So this is the Cobra 2 Max right here. And you can use all default settings, but I changed a couple things and I found them really useful. They were all had to do with the first layer. So I'll show you what's in these. If we go over to the print settings, I should point out, so when you click on this little gear here, what it actually does is take you to the print settings tab right here. And if we go to speed, the first layer speed is 30 millimeter per second. That's way slower than the usual. I think it was 100 or maybe 150, something like that. I like a slow first layer. I got better adherence with that. Then when we go over to filament settings over here under temperature, first layer, I set higher initial temperatures for both the nozzle and the bed. I had problems with adherence, and this fixed it. I didn't change anything else. Everything else is just like it was, so don't worry about those. And I told it to go ahead and use PLA. PLA is like the most commonly used, probably, filament. And, any old PLA seemed to work fine for me. I tried lots of different brands and they all printed. I went through so many iterations of this thing. So those are like the changes that you need to make. And now you're going to go over here and you're going to hit import STL. And let's go find that thing that we just downloaded. It was called Drone Base, I think. Yeah, Drone Base 2.3. And it's big. You see it fills up. Whoops. Don't move it around. It fills up almost the entire build plate. And it's really quite tall also. This is the GPS mast right here. So we're going to hit slice on this thing. Now that we've got all of these parameters set and 10% infill, that is also important. 10% infill, that's the hollow spaces, how much, the interior spaces, how much fill should it have. So we're going to hit slice, and that's going to think for a long time. While that's thinking, I'll show you how it was built over here. I used FreeCAD to create this thing, and I actually wrote Python. I stink at actually making models, like with a keyboard and mouse. So I just wrote code, and when I hit go on this, it will run all of the Python code and create objects. And the nice part about this is I was able to parameterize it. So when I wanted to make it bigger, I just changed some of these parameters, the side parameter or the foot height parameter, and I get a new STL file. And so if you really want to get into this and change it, this is actually the source. I can get it to you, over Google Drive or something like that. And you can screw around with these parameters and make it bigger, smaller, whatever you want. All the things were made this way. We can also just have a look here. I want to sort of show you what it looks like inside. I mentioned that these are hollow. So if I actually, let's delete a couple of these things and change our perspective just a little bit. So you see here, I deleted like I can get them back actually. I got rid of this column right here. And what you're looking at is like a hollow tube right here. And down on the bottom, it's actually not entirely hollow. I had to add a little bit of solid fill here so that we would have support for the battery cage. So if we flip over and then look at this angle right here, you can see right here there's a little slot cut in there, and that's so that our battery cages, which have like it's a keyed slot, so that you can only insert the battery in one direction. I sort of fried the battery once by inserting it backwards. This will keep you only inserting it the correct direction. And then inside here, this is another like subtle thing that you may not have noticed. There's actually like a buildup in these columns that go through here, and that's in order to like pinch the battery. As this thing, if we go look at the front here, you can see that there's like a tiny bit of buildup as this moves into the center, and that forces the battery up higher and higher as it's being inserted, so that it actually pinches up against the top right here, which has the exact same sort of buildup going on, and it pinches the battery in place so that your copper tape is always in contact. If you're struggling where this thing wants to take off and then it loses power, you could actually expand these things right here a little bit, and I'm considering expanding them even more or putting some sort of like rubbery filament in there in a future build so that it's got like a compression layer going on, something that can actually be compressed and gets even stronger contact with the copper tape down here. But anyway, that's what this thing looks like. That's how all this stuff was built. And if we head back over here, if you look at these things, you can actually see like these have become individual filaments here. You can see the lines. Those are the filaments that are actually going to be laid down. So now we have code that your 3D printer can actually run. So you just save this out, and we'll replace it. I already created this, obviously. We'll save it and take it, stick it on a USB, head down to your printer, and tell this thing to print. Be sure you got a full roll when you start. Here's what it looks like as it's printing. When it's all done, be sure to let it cool off before you take it off the build plate. Be very gentle so that you don't like snap anything coming off the build plate. Okay, we've got a freshly printed PLA drone, and we're going to use this stuff. It's called Flex Seal to waterproof all the tubes. Be sure you hit the tubes and the bottom.
I wear gloves and sometimes something over my face, or at least I'm outside because this stuff stinks. Okay, this is dried for actually a couple hours because I was working out at the farm. We're going to fill it up. Eventually, when all these tubes become full, it's going to come out of this overflow here. And one other thing to note, the tube where we're actually pouring this water in is slightly higher than the rest of the tubes. So all of the rest of those tubes are going to fill up first, and then this one will be the last, and we'll get a little bit out of the overflow. There it comes. So now what I'm going to do is dry the bottom of this, move it off of here and let it sit for 20 minutes or something like that so that we can see if we're getting any leaks. Okay, this has had time to dry. Let's give a quick search around here. Not seeing any puddles or leaks on the ground. I can lift the whole thing up, I suppose. Yeah, looks pretty good. Okay, now that you got things printed, you're going to start building it, putting it all together. Let's start with the battery cage. These holes right here in the top are going to be used for the charging, and then this down here is going to be the positive and negative terminals. But first things first, let's just get some of this stuff cleaned up. Take a little sandpaper here. You want to make sure that you don't have any rough edges left after you are done. Next, you want this end down here, this was the build plate side, to be completely flat. So you're going to take a blade here and cut it down to size. Okay, so you want the ends to look like this. That way it's, you know, a smooth edge all the way down, so that when this thing is pushed back and forth here, it will be able to slide in and out of the battery cage really easily. If you did lift up some of the edges here, you can use just a little bit of glue to get those tacked back down. So now we got a pretty smooth outside edge. We're going to work on the positive and negative terminals first. Okay, take a piece of copper tape. I'm actually going to cut mine in half so that it's about the right size. Width, I should say. And it'll sit just like so. So, peel the sticky back off of there, and you'll set it alongside here. It's going to be right in line with that line right there, and then you just wrap it over and fold it on in, like so. Other side, same thing, like so. Next up, take some of this 18 gauge copper wire. This is just doorbell wire, and strip it. So strip your 18 gauge wire, or any wire really. Doesn't much matter what it is. Give it a snip. And you're going to want about, you know, that much. So. All right, now you're going to put these wires in like so. Okay, so they're going to sit like this. This will be power, ground, and then S1 top, S2 top, S3 top. So you'll be able to hook 5 terminals of your charger to these 5 terminals, and that'll charge up your battery, which will sit inside here. So next thing you need to do is tighten these down in place. I use a needle nose pliers for this step. So here you can see one of them that's been tightened. You see I've twisted it around so that it's tight there, and now it no longer wiggles up here. Repeat. Alright, this is what it looks like when you're all done. You've got these various wires here, and you want to clip them off so that they're the same height all the way through. Give you something easy to solder to. So just take your pair of side cutters and clip away. So you end up with little stubs all the way through there, just like you see here. And then on the top, you've got these flat wires. They're pretty taut, and these will be what actually make contact inside of your battery charging tube. Okay, now it's time to solder. Your battery is going to fit right in here, and it's actually going to sit back in this little part of the opening here. That'll give you space between your battery and these charge ports here. So this is the balanced charge cable. You're going to cut it in half and then solder the ends to all of these leads inside here. And this is the XT60 connection that'll connect to my battery right here. So I'm going to choose to make this side over here positive, this side over here, this side positive, this side negative, which means that the red will be over here, like so, and the black will be over here, like so. I'm also going to just elect, because I've got the positive over on this side, I'm going to make this the high voltage, then this will be the top of the 3S battery, top of the 2S battery, top of the 1S battery, and ground. So as I am connecting all of this up, that's how I'm electing to make it connect. All right, let's do that and I'll show you the end result. Be sure to check which side you're going to use here. You want to make sure that it will actually connect to the charge port or the balanced charge port on your battery itself. So this is the side that I'm going to use, and I'm going to make sure that I get just enough wire that I can connect to all those things. So there you have it. If you take a peek in here, you can see that this charge port is connected to all of these in order. The red wire here is on the same side as the red charge port over here. Everything is soldered into place, and I even put a little tiny strip of Velcro right here and then on the bottom of my battery, so that when I slide this thing in place, it'll be held, pinched with that Velcro also holding it. Now you should be able to take your balanced charge ports and connect them up. And the actual port for your battery and connect it up. So that's what it looks like when it's all connected up. And now you can test it all. Get out your multimeter. This one should be about 16 volts, and then each of these should be about 3.8 volts. I guess you can't see those here. Sorry, negative, positive. You can see it's 15.54 volts over there. And then each of these is also connected up. Now, these are live. Don't put anything conductive across here or you'll get smoke. Your battery will discharge. Then you want to do the same thing over here. This is going to be, well, this is the negative, this is the positive. This is 15.54 volts across here also. So our full voltage is coming across to here. So this is what one battery bay looks like. You can easily swap out the battery from the inside when it's done with. And you can also disconnect this. I would actually recommend that. Disconnect these when you're not charging or using. That way this battery is disconnected from the world, totally inert. Repeat that as many times as you need to get all of your battery bays set up. Okay, let's move on to the drone itself. This is what the drone looks like after it's printed. And we're going to start with the battery bay connections. So if I flip this over, you can see that there's these supports all along here. And the first thing to do is actually to take a side cutter like this and clip. You don't want to clip all the way into the tubing here. It needs to hold liquid, but you want to get these supports up off the ground. So you're just going to take a little bit off of, a couple mils, staying shy of those, and then peeling it off like so. You can see I took off the supports all the way around. You don't actually want those things dragging on the ground. Only the feet should be dragging on the ground. They've got a little bit of a angle to them so that they should be able to slide more easily. And this one right here, you're actually going to run copper tape. So you don't want that copper tape dragging on the ground if possible. So now that you've taken those off, let's work on the copper tape next. Be very careful of this GPS mast. If you hit it too hard, it'll break, and then you're gonna have to print a new drone or install a new GPS mast. I prefer to just be careful with it while I'm doing all this construction. So if you can, set things on their side, like so. I'll try to give you a view of what I'm doing. Now if you just run your fingers along the inside here, you're gonna feel a couple little ridges on the inside of this battery case here. And what that's doing is it's slowly pinching the battery into place as it slides in from one side. It's slowly going to get pinched. There's actually a ridge on the top as well that'll slowly pinch it as it gets moved in there. And so you're going to want to run on the inside of those ridges, right here to here. That's where you're going to want to run your copper tape that will actually power all this. So grab yourself a hunk of copper tape like so, pull the back off, and affix it. Okay, so if you look inside of the battery bay here, you can see that there's copper tape right here and here, and that's what's going to connect to your battery bay that you just created. And then on the bottom side of this thing here, you've got copper tape that wraps all the way around and over to this side. And this will make it easy to do just a bit of soldering on this side over here and then run your wires up. So you'll have just little connections, little soldered connections right here, and then the wires will be able to come up here and branch out. You're going to want to have one of the connections over here and one of the connections over on this side so your ESCs can reach into there and make their connections. So let's get to soldering. I'm using 12 gauge stranded wire, and I only have one color, so I'm actually going to take electrical tape and wrap it around here so that I can keep track of which one is the ground and which one is hot, or black and red if you're more used to that. So here's what that looks like when it's all completed. We've got wires soldered all around. These have little green tapes on them, and the wires come right up to the centers here, where we'll be able to connect them to our ESCs and keep each set of ESCs on each side. Now is a fine time to test out your battery connections. You can actually slide the battery case in here. But if your printer's like mine, right here I actually had sort of just a bubble of extra PLA or PETG, whatever you're printing with. And you can either sand it, as I did, you can see the little colors here, or you could take a utility knife and cut that down. You basically want to make sure that this is a tight fit through here. You want to make sure that there's nothing standing in the way of the battery sliding evenly. You can even take in a little extra sandpaper and sand through here. Okay, so here is the battery sliding in. And once it's all the way in, you can kind of wiggle it around and feel if there's any movement. Mine, I can tip it on its side and the battery case won't fall out. You can go the other direction, you can flip it over, etc., etc. Now, the last test you're going to want to do here is actually get out your multimeter and make sure that you have an electrical connection so that what you just soldered on there is actually picking up the voltage of the battery. So you're going to turn this on. And then test, you can see, well, we got it backwards here. That is our 15.5 volts that we were seeing previously, and it's coming out onto these copper tape strips that we just added on here. And we know that we've got electrical connectivity from our battery case, the battery in the battery case, all the way out to what's going to be our ESCs. Okay, next you're going to install your motors. So you want make sure that you get the correct colors of these. You're going to have the black motor over here, white motor over here, black motor here, white here. That's just the direction that they spin. So these two diagonals are going to spin in the same direction. These little hex screws right here are what you're going to use to actually make these installs. And you're going to need a little hex driver like this one. It fits right in there. And these come with the drone motors, or the drone itself. And then you're going to fit these right into here, like so. Now, if you're like me and your printer is got a little bit of print issues around here, you may have to instead take a little tiny electric drill and run it around in there to get that hole completely open. Just go all the way around. And then you can even take it on the insides of these right here if you're having trouble seeing what you're working on. Don't go wild. You don't want to, loosen this or anything like that. But yeah, it's easy to clean this up with a little bit of elbow grease, and it'll go a long way to making this install faster. Okay, now that you've got that on there, you want to make sure that you have this oriented properly. You can see that these two screws right here are a little bit wider, and on the bottom of your battery of your motor here, these two are just a little bit wider. These two are a little closer set. So you're going to want these closer set ones here and the wider ones out there. But you really don't want what I just did, where I put the wires completely pointing away from the center of the drone. So I'm going to take this whole thing, rotate it 180 degrees like so, set it on there, and I can put my first screw right through here and fix it into place. Get them all started first. You don't want to cross thread them, and if you have a little bit of wiggle, it's easier to sort of tip the motor so that you can avoid cross threading these. This is easily my least favorite part of the build. It takes forever, but I couldn't see another way to keep these tubes that we have here, 3D print the whole thing, and still keep this connection really strong, because obviously the motor is going to be tugging on it pretty hard. So just grin and bear it. You're going to have to do this for all of your motors on here. And once done, we're going to connect it up with ESCs. Okay, we've got these two motors here connected. Now we're going to connect up these ESCs to our wire leads coming up here. First, take this lead, strip the end. Okay, whichever side is your ground is going to be connected to the black wire here, and same thing for this one over here. Now you can land all these under a wire nut, as I'm going to do, or you can solder them together and then land them under a wire nut, or tape them up, or whatever you need to do to electrically isolate them. But just for demonstration here, we're going to use a wire nut. And there you go. You got these connected up now. If you want to try to zip tie the ESCs, you can also do that, but they're actually pretty solid here. One more quick note, it is possible to over tighten these screws in here, and if you feel that this isn't spinning freely, that's probably what it is. You'll have to loosen these screws just a little bit, and then these things should spin freely. Also, what does it look like to actually put one of these propellers on? Well, I've got this one here. Now the black ones, they turn clockwise is loose, which is the strange thing. These propellers have just a little notch in them here, and so if you look at the notched side, you're going to put that facing down. It'll fit over the prop so that it actually grabs onto the prop, like so. Then I usually put one of these little washers on, and then because this is black, it's going to go the opposite direction of usual. You'll have to twist it counterclockwise to get that on there, and then I take pliers and actually tighten that down so it's all the way tight. All right, let's hook up these ESCs and then we'll get everything else thrown on. Now while I'm installing these ESCs, I'm also going to go ahead and put this on, and I'll tell you the numbers. This is number 1. Here is number 2, 3, and 4. And this guy right here is the power supply for this, so while I'm installing this, I'm going to go ahead and throw in this power cable right here, this power connection right here. Now while I'm making these connections, I'm going to slip in one extra. This is an XT60 that will connect into here. So while I'm landing these under the wire nut, I'm going to go ahead and slip this connection in here as well, and that should allow me to get all of this connected together. Okay, so the cube is now facing forward. The power connection is in, and it is landed under these wire nuts. So this thing will get power, and it'll be able to sense the voltage of the whole system so that we can come back if we're getting too low on voltage. We've got our motors connected with the black wire on top, white wire on bottom. This is motor 1, 2, 3, 4 connected to the back of the cube here. And I did have to move the cube more to a central location so that all those ESCs will be able to reach it. Now we need to connect up our power right here, and we'll be ready to connect the rest of our peripherals. Next we have our radio. This is the 900 megahertz radio that's going to connect back to our base station. We can just stick that on here. I'm using Velcro for now. This wire right here on the radio is going to come over here and connect to telemetry 1. Next we've got our here 3 GPS. This can be stuck right on top of here. It's our GPS mast, and it's going to go into the CAN 1 connection on the Cube Orange. Now you want to be sure that you have it facing the same direction as the arrow on the cube here. And this nozzle over here, the fill tube and the overflow tube, is the front of the GPS. Next we've got our LiDAR. This is how we're going to keep a constant distance off the ground. And we're going to actually put that right up here, and we're going to go ahead and clear out this support material that's all along here, leaving just a little bit at the top so that this thing has a place to stick. Alright, we can take just a little bit of our sticky here, put it right up here, get that out of there. And now our LiDAR will stick like so, facing downwards so that it can sense the distance off the ground. It's, I don't know, 10 centimeters off the ground, something like that. And like I said, this will connect to the GPS port, I believe.
Three views of the same thing here. It's all about how to connect the TF Mini to the GPS2 port of the Cube Orange. Basically, you cut off the TF Mini connector and solder the wires from the TF Mini connector to the GPS2 connector. It'll come in the Cube Orange package. In the order that you see here. So VDD and pin 2 and 3 are just connected up in the same order. That's pin 1, 2, 3. And then ground, the last port of the TF Mini, is connected to the last pin. That's pin 8 of the GPS2 connector. Be sure you wrap up those solder connections in electrical tape or some other insulator, and then just plug that TF Mini into the Cube Orange. I wish it were easier to do this, rather than crossing pins and whatnot, but it's what you got to do. Otherwise, you'll end up with a much more expensive LiDAR doing the same job as this TF Mini. It's plenty good enough for what we need, so go with this.
Now, this far, we've only talked about the drone and how to fly the drone. And this is what we need here. We've got our GPS, our autopilot, the radio to phone home, and then all the propellers and the LiDAR to stay a constant distance off the ground. This will navigate perfectly well, but we still haven't done anything with spraying. So this is a Raspberry Pi, and for now we're just going to get this stuff installed. We'll actually talk about how to configure it a bit later in the video, or in the series. But what we're going to do is we're going to connect this. It is the really fancy camera that this thing has. We're going to connect it to the front, facing downward and forward, and then we're going to set the Raspberry Pi right here. And we'll actually stick on the pump and the nozzle and the power converter for this Raspberry Pi just all right here so that we've got it. We're not going to actually set it up yet, but you'll at least see how it goes together, and you'll have it in place for a bit later. Okay, so as you can see over here, we've got the camera connected, pointing forward at an angle. We've got the Raspberry Pi sitting right here, connected to the camera. And then over here is a DC buck converter. This is going to take our battery voltage down to 5 volts, which will plug into this GPIO strip over here on the Pi to power it. And then the Pi will also take that voltage over here and use this to control the pump. Now, as you can see over on this side, there are some little tabs all the way stuck down in there. And those little tabs are what are going to hold our nozzle. So let's get that mounted up next. This is the nozzle. This is taken from a mist kit. You can connect your garden hose up to this thing and it will send mist out. We're repurposing it. Just put a little Velcro here, 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 and that's what we're actually going to run through here. Now I have made the conversion here, just used a bit of glue in here to convert from this size tubing to the tubing that we can actually connect up to our pump. And we've already soldered our connection onto the back of the pump. That will be what hooks into this ESC over here. Okay, so we've got this latched on down here to this pipe that goes through, holds the battery. We've got the nozzles stuck in here. They're resting on the holders, and then this tube comes back over and connects in to our pump. And then the very last thing that we got to do is run some extra hose from that pump over to, there's a hole right here. And we're going to send it all the way down the leg of this so that it's sucking liquid from the very bottom of this foot. All right, there you have it. Everything's connected together. Our pump can now suck liquid out of inside here and pump it through those nozzles. The Raspberry Pi, which we'll connect up and just, well, configure and connect up in a bit, is sitting over here, and all this is ready to go. So this side over here is Raspberry Pi and pump, and this side over here is sort of the drone where everything is going to run.
All right, it's time to set up Mission Planner. There's a couple really good reference pages out here. The first one is ardupilot, installing Mission Planner. The second is ardupilot. This one's called First Time Setup, First Flight and Tuning. And the third one is the Cube User Manual version 1.0. So if any of this Mission Planner stuff doesn't make sense to you, you can refer to those three and they'll be a big help. So the first thing you do is just follow the instructions here, install Mission Planner. I've just done that, and here comes Mission Planner starting up. The second thing you're going to want to do, don't actually try to connect to the drone yet. Take a USB coming out of your laptop and plug it in to your newly built drone. Right there is the port. Thing lights up. You don't actually connect over here just yet. Instead, you go over to Setup and you say Install Firmware. Give it just a second to come up. And you're going to install the copter firmware. So put new firmware on this thing. Okay, once your copter firmware has finished install, you're actually going to unplug this thing. And now we're actually going to power this thing up with, rather than the USB, we're going to use our battery. So remember, the battery is keyed, as is the drone. Make sure that you've got the ground on that side, power on this side. All right, the reason that we are doing that is we are now going to pop back over here, unplug this guy, and instead plug in our 900 megahertz radio and connect to that via radio. So here we go. Pop in your 900 megahertz radio. Over here, you are going to hit the, actually, I don't think COM5 is the right one. Let's go to Auto. Connect. Now it's going to try to use the MAV link to connect to our drone. All right, we got battery, and there's the connection just finishing up. So now we have like essentially a data connection to this thing, and there's a whole bunch of things that we're going to want to there's a bunch of things that we're going to want to set on this so that it will run correctly. That means a little different than a standard setup because we don't have a human with a remote control in their hands when we're flying this thing. And there's a few things for the cube, orange, and the LiDAR that we're going to set up. So I created a little cheat sheet for myself. I'll post this also to the GitHub. Here are the links to those two references. Here's a link to how to do the Mission Planner setup and the initial ardupilot firmware loading. And then I say once you get that far, take out the USB cable and connect over your 900 megahertz radio. This is just sort of like proving that this thing will run the way you want it to. All right, so here we go. The first couple things that we're going to make config changes for, let me pop back over here, are the cube orange. And that's so that the cube orange can connect properly and be used correctly by our ardupilot firmware. Let's dive in. The easiest way to get into all these configurations is just to head over here to this config tab and go to the full parameter list. You can like search for each one of these. So I'm actually going to push this over just a little bit further, and I'll try to explain as we go what each one of these things is. So in the search bar here, we just type can underscore, and you see here this D1 protocol. I've already set these. So over here is the name and the value that it's supposed to be set to. What number one does is sets it to drone can. That means that our drone is going to use the CAN port for this GPS that we've plugged in. Then CAN D2 protocol is also 1. CAN D1 driver, P1 driver is 1, and CAN P2 driver is 1. So this makes sure that our cube orange and our here are going to be working properly. The next thing we do is we head over to the GPS type. And here's our GPS type. It's number 9, drone CAN, which is what we just set these CAN D1 protocol to. And then the NTF type LEDs. This is so the LEDs blink properly on our here 3. 231 is what this needs to be set to. This is what the actual built-in LED drone CAN, blah, blah, blah. Those are the actual checkboxes that get set in order to make this thing look like 231. Board safety enable. There is no safety enable switch on this thing. So we want to disable that basically, set it to 0. And now let's take a look at the next set of parameters. So all of these right here came from this website right here. It's the Cube and Here 3 manual. They just said set these things so that your Cube Orange and your Here 3 are going to work. So we did that. Now the next stuff down here, this is all so that we can take off without having a human and an RC in control. There are what things called arming checks. So before you're allowed to arm the drone, that means get it ready to actually fly, it's going to check a bunch of stuff, and some of the things don't make sense for us to check. Auto options, similarly, when we move into auto mode, that's where it flies on its own. We've got to have those things set for our specific use case, I guess is what I'll say. So let's look through these quick. FS throttle enable, just hop over here and search for it. We set it to 0. We don't need to worry about somebody bringing up a throttle as a fail-safe check because we don't have somebody doing that. Arming check, we set it to 1.4. That's barometer, compass, and GPS lock are the only things that I'm checking for when I do the arming check. You could check board voltage and battery level, I suppose, and if you wanted to, the rangefinder, although sometimes I disconnect the rangefinder. Anyway, a lot of these things just don't apply to our use case, and it won't allow you to arm the thing if it doesn't see some of these in place. The big one here is RC channels. We don't have an RC, so we don't care about checking for that. So get rid of that. Auto options, let's see what that one is. Number 3, that's, this basically means we're going to allow ourselves, oops, that wasn't supposed to be checked, I accidentally checked it. Allow arming and allow takeoff without raising the throttle. These are things that, in order to get into auto mode, we don't care about those things. We don't have to have a human operator there to do those couple things. So checking those 2 boxes makes sense. Avoid enable. This one actually, I think I was screwing around with it and I wrote it down as something to look at, but I ended up disabling it. I think that's actually the default. So probably don't need to change the avoid enable. Just set it to 0 since we don't have anything to avoid. And then AHRS orientation, I believe it should be set to 0 by default. I definitely want it to default. That's because our compass and our Here 3, our Cube Orange and our Here 3 are both pointed forward. So there's no changes to the default AHRS orientation. Okay, so those are the couple things we needed so that we could run in auto mode. Now the last thing, we're going to have to do a bunch of stuff to set up the rangefinder. So let's go look at those. The rangefinder is plugged into GPS 2 port, and that happens to show up as serial 4. So if we type in the word serial 4 here, we get a baud rate and a protocol as the first 2 things, and over here it tells us the protocol, oh, it should be number 9, rangefinder, sorry about that. Number 9 over here. And then serial baud is 115. And then the rest of these things are all under rangefind 1. So here we go. Rangefind 1, ground clear, max, min, etc., etc. So max and min are how far this TF Mini can see, 10 to 1,000 centimeters. The rangefinder type, oops, that's actually supposed to be a 19. A 20 is actually a TF Luna, which has a lower range. I tried that one out and it failed. So definitely get a TF Mini, much further range, and set it to a rangefind type of 19. The ground clearance up here actually should probably be 10. This thing is up off the ground about 10 centimeters when it's fully added, put on there. And then that's it. So the last thing we got to do here is write parameters. Yes. Parameters are saved. So that saves that out to our board. Every time we plug in now, those things will be set. We no longer have to worry about them. So if we buzz back over here, there are various other things to check. Let's go have a look at our other pages here. Starting with flight modes, I set them all to auto since auto is the only mode I ever use. I don't think it actually makes any difference, but I did it. Didn't change anything on geofence, didn't change anything on basic tuning, and did not change anything on extended tuning. If you had more aggressive flight, I suppose, you might have to change these PID values. I didn't set those at all, I don't believe. This thing is like the slowest drone in the world, and it turns slowly, so we don't need fancy parameters there. Under the standard parameters here, standard and advanced parameters just show us first the things that we just changed, so nothing much there. And the rest of these are unused. So we're going to head over here to the Setup tab. under mandatory hardware. First thing to check is that you have the correct frame type. You should. You just loaded it. The initial parameter setup, I believe that these are the default values actually. Maybe the battery cell count I had to change to number 4, and it's a LiPo battery. So that's it. I don't think any of these other things were changed. Those are standard values for LiPos, I believe. Acceleration, calibration, we'll get to that in just a second. You are going to do this first one right here. We'll do that before our first flight. Similarly for the compass, we'll do that in just a second, and you have to actually do the compass thing. One thing I struggled with, my cube orange compass was having some trouble, and my Here 3 was not. So I ended up unchecking Use Compass 2 and unchecking the SPI, which is our cube orange compass, and I'm only using the Here 3. You probably don't need to do that. I think I had to do, I might have damaged the thing in a wreck. Anyway, so you could probably use both compasses. That was just me being dumb. Nothing changed. Don't do the radio calibration. You don't have a radio. Under the servo output, it's just motor 1, 2, 3, 4, and then these are, I believe, the standard values, 1100, 1500, 1900 across the board. That just shows what pulse widths are going to be used for minimum and maximum throttle on these things. So those, don't mess with them, I guess. ESC calibration, I don't think I changed anything under here. These are normal ESCs, and everything else is the same. Here you see the flight modes that we set on that previous page. Nothing much to see there. You don't do anything with the fail-safe except check your low battery voltage. You do want to come back home if you run low on battery, so set it to a value that makes sense for you and your number of cells. That's about the only thing you do on there. And then we pop down here to the optional hardware. On this RTK GPS inject page, this is actually an important page. This is where we set up our connection to our base station. And a couple notes here. I'm not actually going to show you, I'm not going to hit the connect button here because it'll show you my username and password. This right here is the format though. So http://username:/pass at whatever the address is for you to get your RTK base stations, and then this. Mine is the Leica network, and it's like all the farmers around here use it for their tractors and GPSs. So this is like a statewide available service. I just got an account on it, and I can connect over the internet to all of the many base stations that are around us. And so that's what I use for my base station. I'll show you what that looks like when I actually make the connection here. You see, I've now got all these base stations that are giving me base station correction information. If you don't live in an area with a bunch of farmers, you may not have this available, in which case you're going to need to pop over here to the IRLock webpage and buy a base station that goes along with your Here 3 GPS. This will do the same thing as what my base stations around here do. So that's all on that page. Now the next thing we're going to do, we've got a rangefinder in here. Hey, look, it's showing us a distance. We can actually lift the drone up now. Let me do that quick. And lo and behold, the distance there is changing because the rangefinder is actually in use. If yours isn't working, give a reboot to your board and then see if it's working after that. I can't remember if I had to do a reboot to get that going or not. And then the last useful thing on here is a motor test. For our motor test here, we've got the drone sitting in a safe place, and we're only going to run these props at 5%. It's worth orienting this thing forward. So this is motor A, B, C, D. And so if we just do a test of motor A, you see me clicking it there, it's only going to spin that one motor. And because the percentage is only 5% up there, it's okay to run it like that. It's not going to try to take off at that. So what I usually do is I run all of these in a sequence, and let's see what that actually looks like. So that's the first motor, A, B, C, and D. Now, the things that you want to check for, you can actually put your hand under here and make sure that there is air being pushed down. The way these things should run is this motor is going to turn this direction, so it's coming into the center. This one turns this direction, goes into the center, and then these two up here, this one's going to rotate this way, and this one's going to rotate
this way. Again, you notice that the GPS and the cube are both pointing forward that way. So that's the order that they should go in, and you can actually look at the props here. I mean, if you look at this guy, you can see that he's high on this side and low on this side over here. And so when he spins in this direction, that's going to force air down. So for every one of these, when you do that test, you should actually feel air being pushed down towards the ground. That's a real easy way to check that you are oriented correctly. I always do this test, before I do my first flight, and we're actually going to go do a bunch of other calibration stuff, and then that same test before our first flight. So it's good to understand what the heck's going on right there.
Okay, we're going to have a couple looks at how to create a waypoints file. You can create a waypoint file right in here. So for example, if you want to create it by hand, you can say, click right here. It's got a latitude and longitude, and you can change that to, say, takeoff. And then you can add another waypoint out here, 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 and then make a second click right there. Okay, and so what we've done here is we take off, we go to this waypoint, this waypoint, this waypoint, and then for our last one here, why don't we change it to a land. So this is just a really simple takeoff, head over here, head here, 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 and land. And this is actually pretty similar to the thing that we're going to create. But you saw me clicking around and it wasn't terribly precise. Oh, one other thing I should mention. Since we are doing terrain type, right here, all of these are terrain, we can actually go ahead and put in an altitude. You see it's already got 2 meters. If you want your thing to fly off the ground at 3 meters, you add that right here. So I don't love creating these things this way. Instead, what I'm going to do is show you a simplified waypoints file that I use, and then I'm going to show you how I actually create it. So we can open this with LibreOffice Calc over here, and it's a tab separated file. So when you open it up, we can do a quick matchup of what's in this file versus what shows up over here. So if we, whoops, did not want to add that. If we scroll to the top here and then check what's over here, the very first line that shows up is useful over here. It's got the latitude and longitude that matches up with this latitude and longitude right here. Altitude is 2.5, and the command type is a takeoff command. It's a number 16 here, and then we've got the second thing. Oh, I'm sorry. Actually, this is just the home command. This is the takeoff command, and then this, right? So home, takeoff, and then 4 waypoints. So we've got a waypoint, 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 and if we scroll down just a little bit here, last waypoint, and then land. So last waypoint right here, and then command type 21 is land. So home, takeoff, land, and a bunch of waypoints in between. The reason I like doing this is I can see the values that are in here, and I can set them, the latitude and longitude to exactly what I want, and I can set these terrain, how high we are off the ground, using our LiDAR to an exact value. Maybe it's a little pedantic. You might be okay just doing clicks, but let me show you just a slightly more complicated file here, and why I like to do this. You can create really easy, back and forth rows through your field. So if we go back to our waypoints file and we open this one, you can see that there are more waypoints in this file, and I have this one other type of command here. It's a 178, which is a do change speed. So let's pull that up over here and see what it looks like in here. You got more back and forth, and then the last couple things bring it back home. So I prefer to edit something like that over here, just because it makes more sense to me. You can even create very square, latitude and longitude positions if you do it this way. So here's your home. Here's your takeoff. That's another command 22, latitude and longitude. This thing right here is a do change speed. So if we head back over here for just a moment and scroll up to the top, you see that after the takeoff, we do a do change speed command to 2.5 meters per second, walking speed basically. Keeps our drone moving slowly. And then we've got a bunch of waypoints, and you can control the values of those waypoints precisely. And then the last thing that you do is land. So I like this because you can make grid patterns over your fields and you can control where things end up. It's a lot easier than clicking too, I think. So edit it in here and then pull it in over here, just to sort of validate that it does what you think. Now, the last thing, these last 3 lines right here are common to every waypoints file that I create. I just copy paste them from one to the next. And the reason for that is it does a landing pattern, if you will. Our takeoff point is right here. Our first waypoint is here, and our do change speed is here. So you can see that it's 345, 345 are the last 3 digits here, and 345, 345 are the last 3 digits here. They are identical. So what happens is this waypoint here is the next to last, and then it lands in that position. And that ensures that the last 3 waypoints we hit always orient our drone in the same direction, which our landing pad sits right here under this takeoff and landing waypoint. And so it ensures that the orientation of the drone is facing in this direction when it actually comes down on the ground and lands. So I just copy paste these last 3 lines into every waypoints file. And that way I'm sure that the last 3 things that it does are land in the same orientation. And then the rest of these you get to choose I actually keep the first couple commands the same as well. So takeoff and do change speed are the same. All I do is fiddle with the in-between waypoints so that I can actually control where this thing is flying, how far apart these are, and get a nice pattern over all my fields to get coverage. So go out and start making waypoints files and maybe do a really simple one for the first one, like this simplified one that I showed you before. It only had like 2 waypoints in it. But once you get up and your drone is running well and you're confident with it, you can go ahead and make more complicated waypoints files like this and just copy the first 3 lines and the last 3 lines into every single one, and you'll have consistent takeoff and landing. So you finished assembly of your drone and you finished assembly of your battery cage. This is keyed, so there's a little slash or a line on the bottom of your battery cage here, and that lines up with the little key opening on your drone here. That makes sure that the black side over here is connected to the red, is connected to the negative side of all of your ESCs, and the positive side over here is connected to the plus. So you can slide this in. Now you're going to connect from over here on your laptop. And you're going to go to the acceleration calibration on your laptop next. So first you're going to set it level, click OK. Now to the left, be sure that you know which direction is forward. The funnel is forward, your GPS is pointed forward, and your cube orange is pointed forward. There's actually an arrow on both the GPS and the cube orange. So this is the left side when you're behind it. Go to the right side. Now nose down. Nose up. And on its back. Successful. Now we're going to head down here to the motor test. I always test these in sequence. And when I'm behind this thing, this is going to go 1, 2, 3, 4, actually A, B, C, D. This one, they all want to spin towards the center. So these, now when I'm behind this thing, these are labeled A, B, C, D, and each of them needs to spin towards the center. You can also check, based on the props that you have on here, your prop should be pushing air down during these tests. So this guy goes towards the middle, this is towards the middle, this comes towards the middle, and towards the middle here. So those are the directions. You want to go counterclockwise, 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 and then clockwise on those 2. So let's give these motors a quick test. We're going to test them in sequence, 5%. There's 1, or A, B, C, and D. Very good. Now the last thing that we want to test on, or that we want to calibrate on this, is the compass. This one takes a little bit longer than all the rest.
I spin around in a circle holding this thing in every orientation possible. So left, right, upside down, nose up, nose down, etc. And that's how I get it through all of its calibration. So go ahead, hit start and watch me spin. When you get an OK message over here, it says please reboot the autopilot. That just means we've got to slide out. Next thing up, you're going to need to load your plan. So if you head over here and take a look at the planning, we are going to first load a file. I'm going to load the drone one waypoints. And then we're going to write that file out. I'm actually going to get rid of a couple of these rows here. There we go. Should head straight out at speed. So now we've written our waypoints file out to this drone right here.
It's time for your first flight. Go to the Mission Planner heads-up display and look at the 3 red circles you see here. For the GPS, just be sure it's connected, ideally with RDK, but for our first flight, 3D connection is fine too. You can also check the battery voltage and LiDAR function if you want, though they've already been checked and should be charged up, so probably not necessary. Then you hit the auto button that puts drone into auto mode, just means it'll fly the plan that we have loaded without human intervention and RC control. And then click arm and watch your drone take off and follow the loaded flight plan. Good luck! Let me know what you think in the comments, and don't forget to like and subscribe for more unique and useful do-it-yourself builds.